2, 6.2. Angles in standard position in all quadrants. So this is where it gets a little bit more tricky. Not only are we worried about what is happening in our first quadrant, we're also interested in what's happening in our second quadrant, in our third quadrant, and also in our fourth quadrant. So I just want to go through a few things. Standard position means that if I'm drawing an angle in standard position, and it's this angle, say right here, I have to have an arrow that goes like this. So remember, standard position is going from the 0 degrees or 360, whichever way you're looking at it, but from the 0 degrees to that line. And this arrow is absolutely imperative. So just as a reminder, this right here is our 90 degrees. This one right here is our 180 degrees. And this one right here is our 270 degrees. So just as a fun little exercise here, what I'm going to do is I'm going to say, let's look at this angle right here. Okay? So this angle, I just drew it in standard position, and it's going to be 30 degrees. What I want you to do is I want you to figure out what the cosine of 30 is. I want you to figure out what the sine of 30 is. I want you to find out what the tan of 30 degrees is. So you can do this in a number of ways in your calculator. It all depends on, oh, I don't want that. It all depends on how your calculator is set up. But in this one, I'm going to say, I'm going to type in my 30, and then I'm going to find out what my cosine is. It's going to be 0.866. 0.866. And if I go the sine of 30, so I'm going to go 30 and then I'm going to go sine, it's 0.5. And I'm going to find out what my tan of 30 is. So I'm going to say 30, and I'm going to go tan, and it is 0.57735. But I'm just going to put 0.577. Now we're going to find way nicer ways of describing these decimals that seem to go on forever, but for now this will be just fine. Now I want to do something else. I want to go over here. I want to see what happens when this one right here is 30. From here to here is 30. So if this right here is 30, that means the angle in standard position, I'm going to do this in a different color. The angle in standard position is like this. So that means that this angle right here would not be 180, it wouldn't be 30, but this would be 180, this line right here, 180 minus that 30 chunk. So this is going to be at 150 degrees. I want you to look at your calculator here and find out what the cosine of 150 is, the sine of 150, and the tan of 150. Okay, so the cosine of 150 it's going to be interesting. Negative 0.866. Huh. And the sine, what do you think the sine of 150 is going to be? 150 sine. Interesting, it's just positive 0.5. Okay, all bets are off. One of them was positive, one of them was negative. So what about 150 and what about the tan of that? Okay, so that one's negative 2. So negative 0.577. There's a relationship between all of these angles because the tan is the same number the sine is the same number and the same sign, and the cosine is the same number. Interesting. Let's do another one. What about this one right here? What about when the angle from here to here is 30 degrees? So then what is that angle in standard position if I would go all the way around to this right here? Well, I would say that it is 180 plus an extra 30. So that is going to be 210. So I'm going to get you to do the exact same thing. The cosine of 210, the sine of 210, and the tan of 210. So the cosine of 210 is going to be negative 0.866. The sine is going to be negative 0.5. But what's kind of cool about this one is 210, you want to find the tan of that sucker. It's positive 0.577. Cool, so again, that relationship continues. Last one. What happens if I have this one, where again it is 30 away from the x-axis? What's that in standard position? Well, oh sorry, I drew it from the wrong thing. It always has to start at 0. That is actually my favorite mistake that I've made so far. Okay, because it really points out that you have to start right at 0. So it's basically the whole circle except for 30 cut out of it. So I go 360 minus 30. So this angle is actually going to be 330 degrees. So let's do our final thing here. We're going to say, what is the cosine of 330? What is the sine of 330? And what is the tan of 330? So what you guys could do, actually, is you could pause the video, find out for yourself, and then you can check your answers. So the cosine here is going to be positive 0.866. The tan is going to be negative 0.5. And, oh sorry, the sine is going to be negative 0.5, and the tan is going to be negative 0.577. Okay, cool. So what I'm going to do is I'm going to just highlight what's positive. So in the first quadrant, all of the things are, all of the trigonometric ratios, let's use our math words here, are positive. In the second one, only the sine is positive. In the third, only the tan is positive. And in the fourth quadrant, only the cosine is positive. I'm going to point out another relationship that circles actually have, and it's pretty freaking cool. If I were to find this point right here, the coordinate point would literally be the length of the radius, or the length of that arm here, times cosine theta, comma, r sine theta. So let's look at these in light of that. So where sine is positive, it means that my y values are positive. And look at that. In the first quadrant, my y value is positive. And in my second quadrant, my y value would be positive. Where cosine is positive is when the x values are positive. So cosine is positive in the first quadrant, and cosine is also positive in the fourth quadrant. All bets are off in the third quadrant because the other relationship that you don't know yet, but is still very much real, we're saying, and you guys will learn this next year, so tan theta equals sine theta over cosine theta, which again makes sense, right? Because if your cosine is negative, that means that your x values are negative. and your sine is negative, which means that your y values are negative. A negative number divided by a negative number is a positive number. See how beautiful math is, folks? This is just, it's absolutely gorgeous. So I just want to draw our attention here is that the reference angle for everything is going to be 30. It's always going to be the one that lives in the first quadrant. And if you understand what the reference angle is, you can find out all of the related angles from there. In the next video, this was specifically looking at what happens when the reference angle is 30, but in the next video, I'm going to talk about what this thing can look like in general and what kind of different formulas and different relationships can we gather from that.